An OCP data center does not use any copper permanent links between the racks. I'm going to try and take you on a journey and try and lift you up and then take you down and then lift you up at the end to show there are opportunities. Now, I'm just helping out the OCP Foundation. The OCP Foundation is a not-for-profit foundation that's trying to encourage open source hardware in data centers. That was the initial idea. In 2011, it started. It's gone much wider than data centers now. It's been adopted by the world's telcos. At the moment, AT&T are converting 4,700 telephone exchanges into OCP data centers. Okay? So if you're in the small construction business, a telephone exchange is just like a small data center. The Dutch are leading the charge on OCP in Europe. If you've got this innovative attitude to pick up opportunities, you'll start to pick these opportunities up fast. And at the moment, in Holland, it's really moving quite quickly. Now, coming on to Orange, this brings me into the telco market. I want to tell you this story about the telcos because the potential for you and your business is huge. Now, what's happening in the telco space? That name up there, openCORD, get it into your head, openCORD. CORD stands for Central Office Re-architected as a Data Center, and it's the conversion of all the infrastructures that were proprietary hardware into OCP data centers. Now, what an OCP data center does, it uses commoditized open source hardware, it runs some software called OpenStack, and then on top of OpenStack, it emulates the proprietary hardware in something called a network function virtualization.
Normally you have a service with hardware and software with different platforms, but now you're looking to one part of hardware with, on the top of it, several intelligent software that will take several services in one platform. So that's a big change for KPN.
Huge. Now, why are they doing it? Because it's cheap, and it's agile, and it's smart. Now, let me show you some things about these opportunities. In the UK, there's over 5,000 telephone exchanges. The opportunity is huge, and the telcos have to do this conversion by the end of the decade, otherwise they'll be out of business. What the telcos are doing are copying what the hyperscalers have done, what the Facebooks have done. They're just copying the technology and applying it into their own infrastructure. And why are they doing it? Because it's cheap and just good enough. These are share prices of two companies. The company at the top is a manufacturer of proprietary hardware into the telco space. Their share price collapsed in 2015. You'll see this all the way through. This company makes open source hardware. Cisco, 25% of Cisco's business is shipping boxes into the telcos. In the last quarter of last year, that 25% of their business shrunk by 12%. As the telcos move into this kind of OCP space, there's no Cisco gear into this space. None of the hyperscalers use Cisco gear. That means that by the end of the decade, by the time the telcos are converted, Cisco's revenue on hardware boxes into the telcos is going to shrink by 25%. Now, it kills things in data centers, which you guys might not like. Okay? It kills things in data centers when you implement it. It gets rid of the centralized UPS systems. It gets rid of access floors. Intelligent power strips that go in the back of racks disappear. It's toolless. In order to be OCP compliant, it must be able to be maintained with no tools. There's no power supplies in the IT gear. So you get a server, an OCP server, there's no power supplies in it. It gets rid of 20th century stupidity. It gets rid of complexity. It gets rid of hardware redundancy because the way you create resilience is you use software combined with hardware to create resilience. You do not use hardware redundancy. But this disconnect When you virtualize everything into these kind of software emulations of hardware, and you float them in software over the hardware, you don't mind if you lose the hardware, certain areas, because that piece of software can go somewhere else and get resourced somewhere else. That's the trick. Okay, that's the way it works. It does away with support technicians. In a hyperscale data center, the ratio of support technicians to physical hardware, in the Facebook data centers, it's 1 technician to 25,000 physical servers. In an enterprise data center, you might get to 1 to 250. It's 100 times less people. So if you've got any of your children who are hardware technicians in data centers, you better tell them to get into software coding, because that's the future. The amount of technicians required in the industry is going to fall drastically. It reduces energy and waste. And I'll put there it reduces low quality, because there's something fundamental to open source development. You get better products faster. And then you remove the proprietary lock-in. In open source, if they don't like it coming from one manufacturer, it's an open specification, they get someone else to make it. And this is simplification. This is really what it does. When you go into an OCP data center, they get very, very simple. Now let's try and discredit 20th century data centers. Why do we use relay racks, 19-inch practice relay racks? Because they are relay racks. If I take one of these electromechanical relays in a railway signalling system 100 years ago and put them in a rack, the optimal pitch between the rounds is 19 inches. And all we've done ever since then is we've bent server metal to fit into 19 inches. What's the module you put into a rack these days? This here is a hard disk drive. The dimension on a hard disk drive is 4 inches wide. If I take those hard disk drives and lay them into a 19-inch rack, I only get 4. So what the OCP rack does, it takes the vertical rail, it widens it out slightly, so you can get 5 in. But the volume of the rack is no bigger. Consequently, you get 25% more hard drives in the rack, which is a benefit on space, but it's also a disadvantage on weight, because that is a very heavy rack. So some of these OCP racks weigh about 1.5 tons. Very heavy, and they come in loaded, because with OCP, you don't build it in the data center, you build it in the factory and you ship it all in. Very simple. I've not seen, to be honest with you, I've not seen any user manuals on an OCP server yet. I don't even know if they exist. Why are cabling interfaces on the back of a server? Cabling interfaces are on the back of the server because all a server is, it's a desktop PC that we picked up, put on a shelf and pushed it into a rack. When you've got an OCP rack full of OCP gear, you don't need to go to the back. And you don't need to go to the back because you'll see men will emphasise, this here is a DC power socket. You just push it into a bus bar at the back. And then you put one interface here, which is the network interface. Now, what have they done? They've basically got rid of the power supplies, the AC inputs, the outbound management Ethernet ports. They've got rid of the miscellaneous operational ports. In a typical server, you might have 4 operational Ethernet ports. An OCP server generally only has 1. They've got rid of the keyboard, the mouse, and the video input. And then all you end up with is 1 Ethernet port on the front. The reason this has a different profile to a normal 1U server that goes across the wide width is because if you make it this shape, it's taller. If it's taller, you can use bigger fans. These are 80mm fans. So inside a rack unit for an open rack is actually taller. If anybody knows the cube law, it's called the fan cube law. And this is the fan cube law. It's a basic, to do with physics. The cube law is this. If you reduce the speed of a fan by half, you reduce the power down to 1/8. So if you use big fans that spin slower, you massively reduce the power. So the fan power in an OCP server is about 1/10 of a conventional server. So what you'll typically see is an OCP server is at least 30% more energy efficient than the equivalent compute facility in a traditional system. If you want to put that into a kind of a number, give you a number. If I've got 40 servers in a rack, conventional, traditional servers, each with their 2 power supplies, and it's 5 kilowatts load in the rack. If I change all of those servers to OCP servers to get 40 OCP servers, based on electricity costs in the UK, you're going to save nearly £5,000 per year per rack in electricity costs. Now, if that's 100 racks, that's £500,000 on electricity saving. Access floors. Why do we use access floors? We use access floors because we used to run water pipes under them. And you put water pipes under the floor because if there's a leak, you don't damage the computer, the mainframe. And then what happened, when the air-cooled servers came in, people started pumping air under the floor and pushing it up through vented tiles. It's the most stupid way to vent the room. You pour the cold air into the warm space and it's denser, it just falls in its own. You don't really need any fan power. You can create a kind of a rotating stack effect, so it's almost passive. Why do we have such good close control on humidity? In a data center, you'll see people have, they say, 35% relative humidity, plus or minus 5%. Yet the equipment they're putting in has a humidity range from 5% to 95%. So why are you doing this close? That costs money. The history is that if you've got high humidity in that room, you can see these printers. The paper used to curl and it would jam. Notice also on that other picture, there's an operator in the room called a computer operator. So you needed the environment for him. You didn't need it for the computing system because it's a water-cooled mainframe. And OCP comes from nobody that's established in the data center industry. The people who started OCP were just a load of really clever graduates that came out of university who had no experience in data centers and just reinvented it all. So let's just quickly walk you through some of the things that come out, and then you'll start to see. This is your traditional. I've got centralised UPS, got chiller units. So let's just walk through what happens in an OCP data centre. So you take that out. Then you take out the centralised UPS. Now, what you get to the concept is called local energy stored. It's all done inside the rack. The UPS is enclosed inside the white space rack. Now these graphics, by the way, they came from Tushar Rabad, who's the data center top guy for Microsoft. Just to give you some numbers, I was chatting to him and he said, doing this and getting rid of all that centralized chiller system and centralized UPS saves them on average, every data center they build, they save $33 million capital cost. Another thing is you get smaller failure domains. One of the biggest problems on a data center is this. If you're going to get major failures, it's often electrical and it's often related to the UPS. When people talk about other systems failing, you can normally track it back to the centralized UPS as a problem. So what they're doing, they're just eliminated it because instead of having a big blast region, you take the whole data center down, you just lose a rack. But because you've got this software resilience, it doesn't matter, you can lose a rack, you don't really care about it. In the Facebook infrastructure, they have, I don't know how many racks they've got there, about 100,000, yeah?
Tens and tens of thousands. In
so let's say they've got 100,000 racks. And they're building, by the way, they've just announced recently another great big data centre in the States. But let's say they've got 100,000 racks. They've only got 7 builds for the rack, 7 types. Very simple. And they manage everything else with software. And that's it. All I've done really is try to warm you up to the fact that things are changing. And hopefully, as we go through the day, I've dropped my business card down, and I'm just here to talk about open source software. And if anybody wants to get involved with it, and get into especially the telco markets, yeah, there's a lot of buzz. If you Google at the moment what's happened, there was a big announcement in the UK. The telco Free just closed a deal with Nokia on it's called the Nokia Airframe, And they're now going to build out OCP and all their infrastructures. And I can tell you this now, it's also happening with other people, other telcos, Deutsche Telekom, all the big players. The opportunity is huge. So that's my bit. Thank you very much for coming, and I hope you find the day useful. And come to me afterwards and talk to me. Thank you very much.